form, and how they grow. Bones form by a process called ossification. It's also called osteogenesis because it's forming bone. Now, when I studied this, I found it quite confusing. So this video is my best understanding of ossification. I hope it helps you out. There are 3 germ layers in an embryo, and they go on to develop all the organs in the body: the ectoderm, the mesoderm, and the endoderm. Bones form from the mesoderm. That mesoderm forms the mesenchyme, and the mesenchymal stem cells can differentiate into different kinds of cells, like chondroblasts, which can form chondrocytes, and these are cartilage cells. Osteoblasts can form osteocytes, and these are bone cells. To understand ossification, we need to go back a little to some things about cartilage and bone. Cartilage can be of 3 kinds: hyaline, elastic, and fibrocartilage. Here we need hyaline cartilage. It has cells in an extracellular matrix. The cells are chondrocytes, which are located in spaces called lacunae, either singly or in groups. The matrix consists of collagen, mainly type 2 collagen, and a well-hydrated ground substance, and these are synthesized by the chondroblasts. Chondroblasts are located in the perichondrium, which is the connective tissue layer that covers cartilage. Bone, on the other hand, has osteoblasts, which develop from mesenchymal stem cells called osteoprogenitor cells. These synthesize the bone matrix, which is then calcified. It has type 1 collagen and ground substance, which gets mineralized with the addition of ions like calcium hydroxyapatite to form the calcified bone matrix. During this process, some of the osteoblasts get trapped in the matrix and differentiate into osteocytes, which are also located in spaces, 1 in each lacuna. Bone also has osteoclasts, which are multinucleated giant cells that resorb bone. They digest the bone matrix. Osteoblasts form bone, osteocytes maintain it, and osteoclasts destroy it. This bone tissue is distributed in compact and cancellous bone. Compact bone is dense. Cancellous bone is spongy, with rods and plates forming trabeculae. Spaces between the trabeculae are filled with bone marrow. This would be if we took a cross-section of the shaft of a long bone. In long bones, the central portion of the shaft, that's the diaphysis, has a medullary cavity filled with marrow. The ends of the bone are called the epiphyses. The expanded ends of the diaphysis are called the metaphyses. The surface of compact bone is covered with connective tissue called the periosteum, and it's got an inner cellular layer which has those osteoprogenitor cells, osteoblasts, and osteoclasts. The marrow cavities are lined by endosteum, which also has these cells. Now we look at how bone forms. There are 2 general ways by which ossification can happen: intramembranous and endochondral ossification. In the end, they both form bone, but how they do that is where they differ. Intramembranous ossification means bone is going to directly form from the mesenchyme, with osteoblasts forming osteoid. This is how most bones of the skull vault and the facial bones form. They are membrane bones, formed by intramembranous ossification. Endochondral ossification involves cartilage. It's right there in the name, chondral, cartilage. Here the mesenchyme forms cartilage first, which serves as a template, and that cartilage gets replaced by bone. Cartilage does not turn into bone, but it gets replaced by bone, and we'll see how in a bit. This is how most bones in the body form, like the long bones, the humerus, the femur, vertebrae, ribs. They are cartilage bones. They form by endochondral ossification. First, let's look at intramembranous ossification. Here, like I said before, there is no cartilage template. Bone directly forms from mesenchyme. The mesenchyme in the area where bone is gonna form condenses. The condensed mesenchyme has stem cells which differentiate into osteoblasts. That's the bone matrix forming cells. They get to work and start synthesizing osteoid, which is the matrix before mineralization has happened. Just the collagen and the ground substance. That matrix then gets calcified. As the osteoblasts form this matrix, some get trapped forming osteocytes in those lacunae. They have cytoplasmic processes that sit in canaliculi. This is an ossification center, and multiple ossification centers form and fuse. The bone matrix organizes into rods and plates, forming the trabeculae of cancellous bone around blood vessels. Between the trabeculae is hematopoietic tissue. Here, mesenchymal cells become blood-forming cells. This is marrow. The mesenchyme around that doesn't form bone forms the periosteum, and that lining the marrow cavities forms the endosteum. The bone that first forms in any process of ossification is immature woven bone. It's irregular and not very strong, and most of it gets remodeled to form lamellar bone. Underneath the periosteum, compact bone forms, and inside that we have cancellous bone. This bone has been formed from the mesenchyme directly. Cartilage was not involved. Endochondral ossification, however, is a little longer. Here the mesenchyme first forms chondroblasts, which synthesize the cartilage matrix, the type 2 collagen and ground substance. The cartilage forms in the shape of the bone that's going to replace it. This is hyaline cartilage, and it has those chondrocytes in lacunae. It is surrounded by the perichondrium. This is the scaffold for the formation of bone. Some of the chondrocytes in the center swell, that's hypertrophy, and develop vacuoles. These chondrocytes compress the matrix, and that matrix starts calcifying. A part of the perichondrium near the middle of the shaft becomes vascularized. That starts changing the perichondrium to the periosteum, because these cells go from being chondrogenic cells to becoming osteogenic cells. They form osteoblasts, which synthesize the bony matrix. This is a subperiosteal bony collar. The presence of bone doesn't allow the cartilage cells to get nourishment. The hypertrophied cartilage cells compress the surrounding cartilage matrix. They synthesize type 10 collagen, osteocalcin, alkaline phosphatase. These hypertrophied cells are thus needed for calcification. The calcification of the cartilage matrix reduces nutrition to those cells as well, so they die. That creates spaces in the matrix lined with calcification. The osteoclasts, that's our bone digesting cells, they form spaces in the bone collar. That allows the blood vessels, along with osteoprogenitor cells and hematopoietic cells, to reach the area where the chondrocytes have died. This is an osteogenic bud, and this area in the center of the diaphysis is the primary center of ossification. The osteoprogenitor cells differentiate into osteoblasts. The osteoblasts start laying down immature cancellous bone. There's a mix of calcified cartilage and calcified bone. This is the calcified cartilage, calcified bone complex. The osteoclasts destroy the portions towards the center, forming the medullary cavity, while the osteoblasts lay down bone around it, so there's remodeling that happens, and this extends towards the epiphyses, thickening of that bone collar and replacing cartilage with bone. The epiphyseal ends develop secondary centers of ossification. They form similarly, with blood vessels and those osteoblasts laying down bone replacing cartilage. The bone that forms in both cases is osteoid, which then gets calcified to form immature woven bone and then remodeled to form lamellar bone. So there is a primary center of ossification in the diaphysis and secondary centers in the epiphyses. They are separated by a plate of cartilage called the epiphyseal growth plate. The surface of the epiphyses have articular cartilage because they articulate with other bones forming joints. These are the only two sites where cartilage remains. The articular cartilage stays for life, but the growth plate, that is responsible for the longitudinal growth of bones. But now we formed bone by endochondral ossification. And longitudinal growth of bone also happens by endochondral ossification. Bone is going to replace cartilage from the diaphyseal end of that growth plate. The growth plate thus can be divided into zones, histological zones. It's similar to how this process just happened. Bone is going to replace cartilage. So there's a zone of reserve cartilage towards the epiphyseal end. That's just typical hyaline cartilage with random chondrocytes. It attaches the growth plate to the epiphysis. Then there's the zone of proliferation. That's where the chondrocytes undergo mitosis. They proliferate and line themselves up along the long axis in parallel rows. Then we have the zone of maturation and hypertrophy. The chondrocytes get larger in size. Then they calcify the matrix. That's the zone of cartilage calcification, where the chondrocytes go to die. From the diaphyseal end, we have the zone of ossification, where along with capillaries, the osteoprogenitor cells enter and form osteoblasts. The osteoblasts can then form bone matrix on that calcified cartilage, ultimately forming bone from the diaphyseal end. But since the cartilage is both proliferating at one end and dying at the other, the rates are almost the same, so the thickness of the plate doesn't change. The bone just keeps pushing it upwards as it grows, increasing the length of the diaphysis, and thus bone grows longitudinally. Once that bone has reached its final length, by then the cartilage stops proliferating. Thus destruction is more and bone replaces cartilage, leaving behind that growth plate as an epiphyseal line. The primary and secondary centers of ossification have fused. Now bone can no longer grow. That's longitudinal growth, but bone also grows radially. Now that's not endochondral ossification. It's from the periosteum, the outer covering of bone. The endosteum lines the marrow cavities, but to make it easier, I'll just draw it as the inner lining. The center of the diaphysis has the medullary cavity. These layers have cells. The osteoblasts in the periosteum deposit bone, that's subperiosteal intramembranous ossification, while the osteoclasts in the endosteum digest bone. Both these processes balance such that bone does increase in thickness, while the medullary cavity increases in size as well. So we've got intramembranous ossification without a cartilage template, and endochondral ossification with a cartilage template. And that's how bone develops and grows. That's the process of ossification. I hope this video was helpful. If it was, you can give it a like and subscribe to my channel. Thanks for watching, and I'll see you in the next one.